So this video is covering factoring ax squared plus bx plus c. So using a method called bottoms up, which is extremely similar to the x method for basic factoring when a is equal to 1. However, if a isn't equal to 1, the method changes and becomes bottoms up. So our first example is, and our only example, is to factor each of these two quadratics. The first one is 4x squared plus 16x plus 15. And the second one is 2x squared minus 7x minus 15. The steps are very, very similar to those for when you use the x method. It's when you start to write out the two factors, or the two linear factors, that you need to slightly alter the process. So let's start with the very beginning to factor these out, and that will be by writing out the x. So you start by drawing your x. At the top, instead of just having c, we're actually going to do a times c. So in that case, 4 times 15 is 60. And then on the bottom, it's still b, which is 16. The process for the middle two areas remain the same. You need to write out the different factors of 60, meaning the things that multiply together to produce that number. So you can do 2 and 30, 3 and 20, 4 and 15, 6 and 10, 1 and 60, and there may be even some others. So beyond that, the next phase is, once you know what multiplies to give you 60, you need to find the pair that will add to give you 16. Pretty quickly, you can see that 6 and 10 will do just that, while the other ones will not. So 6 and 10 are our two factors for the 60 and the 16. However, our factors need to be what will multiply to give you 15. Normally, you would go and write x plus 6 to write the first linear factor, and then x plus 10 to write the second linear factor. However, if we were to FOIL this out, you will see very quickly that it's not going to give us the 4x squared that we need. It will actually give us just x squared, since x times x is x squared. Therefore, we need to do something slightly different than just taking our two numerical factors and going straight into writing the final linear factors. There's a small step in between. The step in between is to redivide out the a that we used to produce the 60. Our a is 4 for this given problem. So instead of just writing x plus 6 and x plus 10, we're going to divide out the a. So x plus 6 divided by 4 and x plus 10 divided by 4. Once you've done this, you need to simplify your fractions. 6 divided by 4 reduces to 3 halves, and 10 divided by 4 reduces to 5 halves. Now, we don't like fractions because, again, if we were to try to FOIL this, x times x is just x squared. We need 4x squared. This is the phase where bottoms up comes into play. What you do is you take the denominator, the bottom of the fraction, and you pop it up in front of your x, bottoms up. So that will give us 2x plus 3. On the second one, again, you take the 2 from the denominator and you pop it in front of your x, so 2x plus 5. If we wanted to check this, you will see that when you FOIL, FOIL, F stands for first, so 2x times 2x is 4x squared. Outside is 2x times 5, which is 10x. Inside, 3 times 2x is plus 6x, and 3 times 5 is 15. If you simplify this, you'll get 4x squared plus 16x plus 15, which checks out as the same as the original question. Therefore, you need to remember that if you are multiplying your c times an a, you need to divide it out from the factors you find in order to get the correct linear factors for this specific quadratic. So the second one is 2x squared minus 7x minus 15. As discussed when we were learning the x method the first time around, if c is negative, that means that you'll have one positive and one negative factor. If the b is negative and the c is negative, then it means that the larger of your two factors is going to have to be the negative. So let's begin. Again, start by writing the a and c at top. So 2 times a negative 15 is negative 30. b on bottom is negative 7. Start to write your factors of 30. So we already have negative 15 and 2. You have negative 10 and 3. You also have negative 6 and 5, and negative 30 and 1. Once you've written all of these different factors out, you go back through and figure out the ones that will add to give you that negative 7. Negative 5 plus 2 is not negative 7. Negative 6 plus plus positive 5 is not negative 7. And negative 30 plus 1 is also. However, negative 10 plus 3 does equal negative 7. So therefore, that would be the two numerical factors that we need to use for our process. From here, we go into writing out the two factors, remembering to divide out the a, which in this case is 2. So you get x minus 10 divided by 2, and x plus 3 divided by 2. Now, in case you did not remember, the reason why the 10 is negative is because we want our b to be negative. So the only way that's going to be possible is if the larger of the two numbers is the negative. If this had been reversed, 10 minus 3 is positive 7, and we aren't looking for that. That would be a slightly different polynomial. From here, you need to take your fractions and reduce them if possible. If they are not reducible, then you can go straight into bottoms up. I'm just going to reduce first. So the 10 divided by 2 reduced to negative 5. Negative 5 no longer has a fraction. The 3/2 doesn't reduce, so now we need to take the denominator of 2 and pop it in front of the x that it belongs to. So we have x minus 5 times 2x plus 3. Okay? And again, that is the method called bottoms up. You have to remember to divide out the a. If you do not divide out the a, you're going to end up with two very different linear factors that will produce a very different quadratic than the one you are actually trying to factor. Your two u-tries. So 3x squared minus 15x plus 4, and x squared plus, or 6x squared plus 7x minus 3. Remember the different steps. Start it off the same way as you would any given x method. And then remember, once you have found your factors, that you need to divide out the a, because instead of just c at the top, you need a times c. And that is the end of this video.